The EMC VSI plugin for vCenter provides VMware administrators the ability to view, provision, and optimize their EMC storage systems. In the next 15 minutes, we are going to show you how to set up access to an EMC VNX and provision block and file data stores using EMC fully automated storage tiering or fast pools. You will see a VMware data store moved online in its entirety from disparate storage types. Next, we'll demonstrate the impact of storage I/O control and VAAI hardware acceleration in a VMware environment. And finally, we'll briefly cover VMware integration with Unisphere, the element manager for the VNX storage system. Let's go ahead and get started. VSI has a feature manager utility that shows what plugin components have been installed as part of the virtual storage integrator framework. In this case, both path management and the unified storage management plugins are installed. Let's set up access to a VNX. First, we need to choose the storage protocols we want to use. In this case, both block and file protocols are applicable. Here, we configure management console information. The IP address and login information are necessary so that vCenter is able to authenticate against the VNX and leverage the storage system APIs. What you don't see happening here is that the storage administrator has created pooled resources specifically for VMware. Using role-based access control, the storage team can provide the VMware administrator access to a subset of storage resources on the VNX. This concept of providing resource pools up the storage stack is what keeps the storage team out of day-to-day VMware storage administration tasks. It looks like our VNX added successfully, so let's get started. First, we're going to create a new block data store. From this screen, we are going to right-click on the ESX cluster and choose EMC, Unified Storage, Provision Storage. We are prompted with a dialog box allowing us to choose either block or file types of storage. The VNX system we added in the prior step is available for provisioning here. On this screen, we are able to view the pools of storage that have been made available by the storage team. We are going to select the fast pool with a mixed disk type. And finally, we are prompted to enter a data store name and to configure the VMFS block size. Notice that raw device mappings can also be created using this interface. We are going to give the LUN a capacity of 1,000 gigabytes and make this data store thin, which means it's only going to consume storage that's actually used. In the advanced settings here, we can also configure the storage tiering policy for this device. Here in the taskbar, we can see the different steps executing both on the VNX and inside the VMware cluster to make storage available. We're going to repeat the provisioning process, this time to build NFS or file-based storage. We'll give the file system a name, File 01. Now, we select the NFS server and the network interface that we want ESX to mount the storage from. Again, we'll select a fully automated storage tiering or fast pool so that VNX manages what tier of storage the active chunks of data will reside in. Note that some data may be on flash, others on SAS. Fast cache is also enabled here. And the ESX timeout settings box will update the cluster kernel settings using EMC's best practice recommendations for NFS. Here in the taskbar, we can see the different steps executing both on the VNX and inside VMware to ultimately make storage available to the cluster. As you can see, each ESX server now has 2 new data stores mounted and ready to go. Let's take a quick look at the EMC Path Management add-in. From this screen, the VMware administrator is able to configure the multipathing settings for all storage devices in the cluster. Because the EMC devices are managed by PowerPath Virtual Edition, you can see that they have different configuration options. The plugin can be really handy because most VMware administrators have become accustomed to using scripts for managing pathing inside the cluster. This is because there's no easy way to make a large number of pathing policy changes from inside vCenter. Note that neither PowerPath nor EMC storage are required to use this feature. The purpose of this section is to demonstrate online LUN migration independently or outside of vCenter. Let's say that the storage administrator created a pool that didn't have sufficient resources. Recently, end users have been complaining about performance. Rather than using storage vMotion to move all of the virtual machines around, we can use the VNX virtual LUN migration option to move storage devices online and non-disruptively. What you see here are the properties of the data store before the migration. Note that the pool type is a RAID group, and no advanced tiering options are available. Let's jump over into Unisphere and look at the same LUN properties. Here, we see that the VM data store LUN is currently configured in a traditional RAID group, and the Disks tab shows that the device is actually housed on 5 physical SAS drives. To enable the migration, we need to create a new target LUN of at least the same size. In this case, the data store is running low on space, so we're going to make the target device a little bigger. Next, we're going to right-click the source LUN and click Migrate. We choose our newly created LUN and click OK. A warning is presented letting the administrator know that the target device is larger than the original. OK, the migration initiated successfully and will take approximately an hour to complete. Rather than wait, let's warp forward in time. Now that the migration is complete, let's review the LUN properties again. Notice that the LUN is part of a fast pool with mixed drive types. And a tiering tab is now available where we can set data movement policy specific to this storage device. We're also going to look at the properties of the fast pool that our LUN is using. Attributes such as used capacity and subscription ratio are available here. The Disks tab reveals that both SAS and enterprise flash drive types of disks are in use by this pool. And then under Advanced, we can see that fast cache support is enabled to augment performance on the non-EFD drives in the pool. And then finally under Tiering, we are able to review the fully automated storage tiering statistics. Additionally, we can review and modify the scheduled times that data relocation jobs execute. Let's flip back to vCenter and review the data store properties. Here we see the data store is now serviced by the fast pool. This time, we click Advanced, and we're now able to configure a tiering policy because the data store has been moved to a mixed drive type of storage pool. You might remember when we migrated the VM data store LUN earlier, we created the target device with extra capacity. Next, we're going to grow that data store by adding the additional 50 gigabytes. Using the Data Store Configuration tab in vCenter, we can increase the data store size online, assuming that the underlying LUN has additional space to grow into. What you see here is an example of a VMware file system, or VMFS grow operation. That's outstanding. We've just increased the size of the data store from 250 to 300 gigabytes. In this section, we're going to do a quick demonstration of storage I/O control, or SIOC. This VMware feature is useful because it can help prevent individual virtual machines from monopolizing shared storage resources. We've set up Iometer to run from two different machines, Mail01 and XP01. And now that we've got a workload started, let's go ahead and set up an I/O limit for Mail01. Here, we change the IOs per second limits from unlimited to 1,000 for each of the two disk devices. As we look back at the Iometer load, we can see that the number of IOs per second has dropped into the 2,000 range for Mail01. IO traffic on XP01 was unaffected. Next, let's look briefly at the impact VAAI has on storage vMotion operations. First, we're going to need to disable hardware acceleration on one of our ESX hosts. This is done by setting the hardware accelerated move parameter in the ESX kernel advanced settings to 0. Next, we are going to go ahead and initiate two simultaneous storage vMotion activities. The first storage vMotion is started on a virtual machine named CRM01. This runs from the ESX server with hardware acceleration enabled. The second storage vMotion operation is started on virtual machine DB01. This runs from the ESX server with hardware acceleration disabled. As the storage vMotion progresses, we can see the impact on write activity coming from the ESX servers. Notice the amount of data written is roughly 50% less on the ESX server using VAAI hardware acceleration. Let's go ahead and explore one of the VNX storage efficiency features, data compression. Here, we're going to right-click on a virtual machine and using the EMC Unified Storage option, click Compress. A compression task is initiated and any compressible used space is squished out of the virtual machine. This operation can be performed either on individual virtual machines or on the entire data store. Now, let's look at the compression rates. In this case, we were able to gain close to 25% capacity savings. This improvement is on top of the efficiency gains we have already achieved by leveraging VMware thin provisioning. Finally, for those storage administrators that struggle to understand what the VMware administrators keep talking about, we've got some help. Unisphere is the storage administration console for the VNX, and it's VMware aware. Here we've configured Unisphere with the VMware vCenter console information. Once this relationship is set up, Unisphere is able to recognize both ESX servers and their associated virtual machines. We can see name, IP, and version information in detail by drilling down onto the ESX server. Or we can even select individual virtual machines and get IP, operating system, and even storage layout information. This data is correlated at both macro and micro levels of the VMware environment. As a result, the storage administrator is now able to understand the VMware relationships right back to individual LUN and storage pool devices. Conversely, when we jump back over to the EMC VSI tab in vCenter, understanding storage system serial numbers, device IDs, pool membership, thin or thick provisioning attributes, and storage system version information are a breeze. Detailed information is available for both block and file data store types. Block data store information is also organized by LUN and target so that a path management view is available. Here we see 4 active paths to a LUN using the Fiber Channel HBAs installed in the system. Additionally, there are 2 other paths via iSCSI that are operating in standby mode. PowerPath Virtual Edition is handling path management and is ideal for heavy I/O and dense data store types of configurations. And finally, when the storage team says that LUN 0 through 3 are going to be involved in an online maintenance event, the VMware administrators will know exactly what data store devices they're referring to. This concludes our tour of the EMC Virtual Storage Integrator. I appreciate you taking the time to watch this recording, and if you have any additional questions or want to learn more about EMC products, please visit www.emc.com or contact your local EMC account executive or vSpecialist. Thanks for watching.